I'm Mas. So my team has a couple of products that we manage, but today we will focus on Marconi. Since it was the first product we started to automate with SaltStack, it was like last year, like 11 months ago. So we'll talk about what is Marconi, and we will focus about why we like it because the way we deployed it. We talk about why we use SaltStack and the reasons behind we chose SaltStack. Then I will talk about universe and environment metaphor, which I think was a mistake. I will tell why. Then I will talk about Salt concepts that we use to automate our environment. Then I will talk about the framework we implemented. So with this framework, actually, we are able to do what I'm going to tell you. And then we'll go over what we talked. So Marconi is an OpenStack project. It's open source. It's in Python. It's a message queue. It provides a RESTful API, so you can talk to Marconi through HTTP, HTTPS, which is kind of good because then you can provide a web service. Like another queue system, or message queue system, it lets you push a message. So when you push a message, you basically create a small amount of data in the queue. You push one more, there's one more message in the queue. Then until you claim them, they stay there for a while, right? And then you claim them, they go away. So it's like another queuing service. The good thing with this is the way it's designed, it supports multi-tenancy. So you can have more than one customer running on the same environment. They won't ever talk to each other. They won't ever read each other's data. And like I said, it's a RESTful API, so you can provide this as a service to your users or customers, internally, externally. So since it's open source, if you choose to deploy it like we did in 6 different data centers around the world in 4 different continents, if you use like 360 servers, you could get like 5 billion transactions per day out of the system. So this number looks like remarkable. It's like 60,000 requests per second, actually. But if you double the number of servers, you can get 10 billion, then 15 billion. It can scale to some extent. But the point is, I will talk about something more remarkable, I guess, at least at this event. So let's talk a little bit about what we have in the environment. This is a huge list. The point is we have lots of different roles and devices or minions, let's say, in the environment. So we have load balancers. These are the only physical devices we have. We don't manage them. We just use them, let's say. Then we have web servers, lots of them, obviously. Catalog databases, these are MongoDB implementations. Each of them has like 3 nodes, 1 primary, 2 secondaries. We have catalog data. Queues databases, these are the shards where we store the queue information. We have lots of those. These actually define how fast your queuing system is. Then we have a Xenos master. This is in one particular location. It has talked to all other collectors in the environment. And these collectors are in 6 different data centers. We have Graylog servers to collect the log information, Nextdoor servers to search them, index them, obviously. We have bastions as an entry point, so we can only log into bastions, and from there we log into other servers. Bastions just let some specific set of VPN IPs to log into. And for usage monitoring, we have a couple of workers in the environment, in each environment, actually. And then we have databases associated to that. So we have to collect data and aggregate that results that input into the database. So we do this in each environment. And there's a huge relation between those components. For example, database servers will just talk to web servers. We don't want any other server to talk to database servers. And I should say this, we deploy Marconi on top of our cloud servers. So it's like we are a customer of cloud servers. This is running on the cloud environment. So it's a public environment. We have to set rules specifically based on the IP addresses. We cannot give a range of IPs. So there's a huge relation between those. Bastions are the only SSHable servers. You can SSH from them to another server, so they have a specific set of rules on each one of these servers. Then there becomes a matrix of configuration files. It's a huge set of files. And we have to do this on all locations. So let's imagine that at the beginning of this talk, we had nothing, just a user account, just a cloud account, just one account. And we go and start deploying 3 US locations. These are different data centers. And then one London, then Hong Kong, then Sydney. So what is remarkable is it will just take 45 minutes with the framework we have right now. So I will just talk about this. I will talk about how we implement this, what we had to invent or what we had to use that salt stack already provided. But before that, I just want to talk about why we use salt. I think it's also why anybody is using salt. The first one is simple one, human mistakes. So I think this is the first reason that configuration management tools came out, right? Like in 1996, when I was at my first job, I was managing a Unix server. By then, this Unix server had a nice, beautiful name, like Hurricane names. So we would give names to servers because there were less number of them. We would love them. We would spend all day on one single server just trying to manage a single config file. And this server was a web server. We would run Apache on this server. So it was easy. All I would do was that. I would just change that config file all day long. Then there came another server. We gave it another beautiful name. Then came another server. And at some point, we start to lose track. So we start to lose what we have changed where, which file we updated where. And we started to make lots of mistakes, obviously. But by then, we didn't know that we could manage this in a clever way. So we had these SH tools, stuff like that. This is kind of the very basic problem. I think it has been solved with any configuration management tool already. The other problem is scale. So in our implementation, we have lots of servers in lots of different environments. So we have to deploy or push that same config file into lots of different servers. So this is more about a distribution problem, how you can distribute that file quickly and how you can restart the service to show that config file. I think this is bigger than scale problem. Scaling is a big problem. That's because, let's imagine we have 30,000 servers in one environment, but nothing changes there. No server fails, you don't ever change anything. It's not a problem, right? You had that problem at some point, but now nothing changed, so you don't have a problem. As soon as you want to change things, as soon as it becomes a dynamic environment, you want to add servers, remove some servers, change IP addresses, then it's a problem. You have to adjust your system so you'll be able to manage this environment easily. You don't want to manage thousands of config files individually, right? You want to have rules. So you will set a rule for some type of servers that's going to be deployed on a set of servers. Oh. Then, I think in many cases, probably you guys have like production DR or different physical locations or test and prod environments. So they look alike, but they are not really same thing, right? There's at least one thing different. A low balance IP address or something, at least something is different. That's why they are not the same environment, they are different environments. So when you have to manage multiple environments, the problem is you don't want to create that same config file once again for that new environment. It was our problem at the first couple of weeks when we started to play with salt. So we did this test environment for Marconi. It was awesome. We finished everything. We said, oh, we are ready. And then, OK, we have the production environment. Actually, it was a preview environment. And then we found that we had to create everything from scratch, like config files with different names, new salt masters. So it was too much effort. So instead, we had to find a way that we could use the same salt master, same formulas, but they would be, or state files and pillar files, but they would be applied differently in each environment. So this is the problem that I'm trying to solve. I will tell you how we solved it. Before that, I will talk about this metaphor. So usually you will use a metaphor because you would like to describe something hard to understand with something easy to understand, right? So I came up with this parallel universe metaphor, but it came out to be much harder to understand than environments problem. So I was watching this documentary on BBC, and so these scientists were trying to observe electrons, these small particles. And they found that they exist in two places at the same time. So a particle, an object, is in two places at the same time. It's interesting. Then they found that it is not a particle, it's a string. It gets complicated. Then they found that it's not a string, but it's a membrane. And then they start thinking that there are multiple universes, each look alike, but there are differences between them. So in one of them, I'm here, you are not. In another one, you are here, I am not. So there are endless possibilities. And I thought it sounds similar to environments because in most of the cases, we have similar environments with small differences in each one of them. But still, we have to manage that. And we would never like to have one config file leak into a different environment. So that would be a disaster. We would have a test config in production or something like that. So in environment, universe, let's say we have laws, right? Laws of nature, like we have gravity, we have magnetism. So without them, we can't define the universe. Or I could say, universe is defined by the rules or laws. And same applies to environments. We just want to have proper rules that will define the environment. So these rules will be processed a bit differently in each environment based on the inputs, but they will be still same and manageable. So it was a bad idea. It was a hard to understand concept, but it was too late to change. And so we use some of the SALT concepts more than others. I will just go over them quickly, so we will be on the same page. Some of them are simple, like as grains. Probably you all know right now, grains live on the minions. It's like a key value pair. Some of them are there by default, like OS type and things like that. And then you can set new grains. This is the very fundamental thing we use for, I think, everything else we did. Then we have pillar. Pillar is on the master. So you distribute pillar data to minions based on some rules you set. So we use this mostly to set default values for the configuration files. And we use this to identify environments from each other. So the very first thing we did was when we had to have test and preview environments, we just created two pillars, right? Test pillar and preview pillar, and then we will put the different values. But then we found that we also have to change state files because this test environment will have a newer version of some software, but preview wouldn't have. Then this wasn't enough on its own. And SALT also have environments. This is basically a simple setting in a config file, in SALT config file, and you just say, if I say this, if I say prod, look at this folder. So that's so simple. If you say test, it will look to a different folder, and it will find all your state files and pillar data there. So this is an important one for us. And then this is another important one, directory overlay. So do you guys use this at this point? Yeah, this is pretty nice. What it does, do I have an example? Yeah. So what it does is you provide, so in SALT master config file, there are two sections, file roots and pillar roots. And for any environment you define, like production here, you can give a couple of folders. So it will look, let's say you want to look for one.sls file. It will first look at this folder. If it cannot find, it will look at this folder. If you have one SLS here, two SLS here, then it will, both of them will exist in that environment. You can use any one of those. It will just merge both folders. If you have one SLS here, one SLS here, then it will ignore this and just will use this one SLS file there. So this is pretty useful. And like in this case, we just use this to define environments in terms of file mappings. So production is like this. I will show you more details later for tests and different environments. So when we create when we start to have these many environments, we had to find which servers in which environment. So we had to query, let's say, environment to find out what other web servers I have in the same environment, or what other database servers I have in the same environment. So mine gives you this functionality. It's a simple setup in the config file. Do you guys use mine? Anybody use mine? Yeah. So yeah, it is interesting. So it's a simple config file in SALT minion. You just enable mine and you say what data you want to publish to master. So each minion, will just, in our case, grain data. They will publish grain data to master every once in a while, I believe every minute. So master then will know everything about all these minions in the environment, all the grain values, for example. Then the good thing is, from another minion, you can query that information. You can say, give me all the web servers in the environment. So a MongoDB, for example, database server can say, give me all the web servers in the environment so I can give them access. So it will just give access on the firewall level in the host name or in the connection string. This is useful because if you have like 10 servers there, if you want to add 11 servers, it will do it on its own. It will just change the config file on its own because it will know that there's a new server in the environment. It will just add that new server into its configuration file or configuration section. So this saves us lots of time. And then we use map a lot. This is usually for the first time when we provision environments. We create this map file. This is basically a definition of all the minions you want to have and the grain values you want to associate them. So we use this a lot. And we use overstate. So overstate solves a nice problem. In the past, when I used different configuration management tools, the problem I had was I would have to create replication between two databases, right? So I would install two database servers first, and then I would have to run one more command to create that replication. So it's like two phases. But Salt has this overstate mechanism, so you can say just this, so many lines, but so you can first say, if you match this, it's MongoDB.org environment, and if it has a MongoDB server role, then run this Mongo server SLS file. It requires something, ignore that. And it will first finish this for all the MongoDB servers in the environments. If you have 10, it will do that 10 first. When they're all done, if there are no problems, it will run the second one because there's a required statement there. So it will find MongoDB servers, but the ones which is primary in their MongoDB role, green, and then it will set up the replication. Because you must have all servers in place to be able to set up the replication. So it's a pretty nice, this is useful when you are creating a new environment from scratch. These days we have to create test 1, test 2, test 3 environments all the time because developers want something different to test, something strange usually. So we just use this to create environments quickly. So I'm going a bit faster than I should, but framework. So with all these things I mentioned, we built other things. So we came up with something called role. Probably all of you guys have something like this. So we defined a role, which then defines what needs to be installed on that server. It defines packages, it defines configuration files. But it's not just a single thing, it's a couple of things. It's a grain, first of all. So we assign this role grain to the server. It can be web server or anything else. And then, remember, we have like 10 or more than that number of roles. And then in the formulas, we started to check that role. So instead of like pointing a specific server to run a role, we run all roles on all servers. But each formula has this if-else thing. So if roles in grains, and then queue servers in that role run this formula. So then we don't have to worry about what to run where. We just run everything everywhere. But the formula will check if it's the right server and it will run, otherwise it won't run. Again, we have to do this in a couple of environments, in like 10, 11 environments right now. We just don't want to deal with details. We just want to run everything, and we'll just have to figure out where to run. Then we have minions pillar. So in minions, we define each minion. And each minion always has a role. And they have some attributes. So role is what I just mentioned. It's a grain value. And then attributes are related to what that server is for. So a MongoDB server has MongoDB cassette attributes, which is what it is. Then it says what is role, primary, secondary. And then database type, it's specific for our environment. It's named catalog. So then we have web server role. Again, we have a queue server role. It's assigned to this server. We have lots of these servers. It has this thing which matches that one. So this server will use that server as a MongoDB instance. And this is something else about the deployment. Then we also created devices. So basically, we are talking about minions, devices, networks, and networks. Yeah. So then we created devices pillar. These are the things we cannot really manage with Salt. They have APIs, but we don't really able to manage at this point with Salt. So we put those because we use these in different formulas. Like the load balancer here. And the last one was networks. This is something we have no control over. We just know what those IPs are. And for example, this one is used for Bastion servers, so we know what can access, which networks can access to that server. And it's about Saltmaster. So with all of those, we have to define the relation between different parts of the system. Like I said, I have different environments, and I want this firewall rule to run differently in different locations. So for that, we created roles pillar. This is kind of a layout of the pillar. It has roles as a key, and then values another key pair. So role is like MongoDB. Then there's the tags, there are some attributes, there are some flags. Attributes are assigned to the server as soon as we create it, but flags are assigned during the runtime. So let's say when you set up a MongoDB replica set, you just set it like, yes, assigned or is created. And then we define what are the clients for this role. Here's an example for that. This is a MongoDB server role. It's some attributes. So these must be here, otherwise some other formulas will not run because they check these to exist. If you don't have these in this, if you don't have these assigned, that formula will fail because it requires these. So this attribute section tells what is required for that formula to run. So if I create a MongoDB server role, but I don't set the replica set, it's pointless. It won't just run. And the flag is something like this: MongoDB replica set configured. It's like true or false statement. If it is true, it won't run again the same formula, obviously. This is for the clients. So this is another example for minions. Here we define the role, Bastion server. So this basically says, I'm sorry, just a sec. Yeah. So this defines one important thing. It says any server with MongoDB server role, let me show it like this, can be accessed by Bastion servers over TCP using this port, using these states. So this is SSH access definition actually. So my firewall state file template, Jinja template, will read this and will find all the servers that has Bastion server role in the environment, and then it will find all the MongoDB server roles, and then just will create that huge firewall list for that server. So this, because of this, I don't have to mention each firewall rule on these servers, on each different environment. This is a bit longer than that in terms of roles. So here we have lots of roles. It says any server with MongoDB server role can be pinged by any server with those roles in the same environment. It's pretty easy. So if I create one more server, I don't have to care about the firewall rules. It will just do it for me. And again, it's very important for us because it's on public cloud. It's public IP addresses. Any IP can be anyone's. If you power off a server, someone will pick up that IP address, so it will be someone else's IP address, and he can log into your server. So we have to run firewall rules every time we make a change in the environment. If we add, if we remove, we have to just run it again. But we don't have to think about it because it will just handle its own configuration file. This is about, again, ping, but this time this is for a network. So these are parts of the config file, though. It's a longer file. So MongoDB server have lots of sections like minions, networks, and devices. So this is the one for web server. This is pretty nice because it just lets web servers to be accessed from load balancers. So no one ever can make a direct request to my web server. They are just accessible through the load balancer. And here's the port. Here's port and states. So basically a HTTPS connection. So we have all this in place, but still it's not enough to define the environment. We still have to find a way to identify one single environment to run those. So Again, environment is the main things. We have to do a couple of things here and there to define an environment. So first of all, we created 3 grains on each server we create. One of them is project. Project is, in this case, Marconi. But we have other environments that we manage, or projects we manage, so we have different project names for them. Because initially we thought with one Saltmaster we would manage a couple of projects, but then we gave up that idea. Right now we just manage one project with one Saltmaster. So project is Marconi for this case. Purpose is like it's dev, test, preview, production. Purpose of the environment. And a location is the physical location. It can be a data center, in our case ORD, London, Sydney, whatever. Or it can be like a rack. It's a physical location. Then we merge all those because mine doesn't let you to query more than one grain at a time. You can just query one grain. So we merge all of those like this project purpose locations, like Marconi prod ORD, for example, as the environment ID, and we assign to this each minion. So now that, remember that map, we have 6 different locations, each one of them different ID, so they are different from each other. And what is good with this is I have roles like Xenos. Xenos server has to talk to all servers in all environments. The master must talk to London, Hong Kong, Sydney, whatever, all of them, while my MongoDB in ORD should only talk to my web service in ORD. So I use project there to define what that Xenos server can talk to. But for my database server, I just use environment ID because it's more specific. And then I can also choose my test servers by using this purpose one. And I can do a change on all my test servers. So we define, and then we define environments in the Saltmaster config file. This is something I mentioned before. It's a better example for that. So first we define a base. We don't really use this environment as an environment, but we just define it here. And we put everything under that. All firewall formulas, I don't know, Memcached, MongoDB, web server, MacroSGI, whatever we have. Everything's under base. So it's what it says, it's a base environment. Then we create these new environments like Marconi Prod London in this case. So this directory overlay again. So everything I have here, right? If I don't put anything here, it's almost fine. I just have to have pillar data for this environment. So imagine I have test environment, I don't know, 10 servers. I have product environment, 10 servers. The only thing I want to change is load balancer IP address, so it's a pillar data. So I can just put pillar data here, and they will be exactly the same. I will just put one single file, and I have new environments. But then in test environment, I want to install some other package. I want to have, I don't know, Nginx. But in production, I don't, because it's test environment. I want to test it there. So here, then I come here, and I just put Nginx SLS here. Sorry, this production. Here. It's just one single file difference from base. It's not here, it's just here. And now I have Nginx in my test environment. When it passes the test, then I can move it to base. So it will be available for all my environments. I have like 10 of those. The only challenge here is if you had a new environment, you have to change this file. This is etc Saltmaster file. And you have to register Saltmaster. That's the only downside. But it's pretty easy. So in our case, all the environments looks like this. We have a couple of more. It's all under the same folder, base, preview, blah, blah, blah. And for different products, we have the same setup. So we use project name here, and then all the environments, we use the syntax. And all of these are under GitHub. So we just pull from there, we test in our own environments, and then push. So I want to show you about some formulas about how we use mine in our formulas. So that is actually where we get the most out of everything I have told before. So the first one is the famous firewall template that I mentioned earlier. It's a long, like I think almost 200 lines of templates. It has lots of if and else statements. It's kind of long, but let's go over it. So remember, we had this minion notation in the roles file. So we have minions, and then there are roles. So this first check the minion, scope. If it's a project like Xenos server case, it's all environments, it's environment ID, it's just environments. Here it is. So it will check the scope, and then using mine, it will find, so remember this runs on the minion, right? So minions, a minion, let's say a web server, is running this formula or this template. So first it gets what it is. It says, okay, I am a web server. And then it starts to process this file. So it's a web server, so it will get all the minions in the same project, and if it will try to match the role, if it will match, it will just put into iptables rules file. There's some other things above before this section, so it will just add some line of, a single line actually in this case, into that configuration. If the scope is environment ID, which means it's just a single environment like Marconi prot ORD, then it will use environment ID, it's a small scope, and it will just find the service there and do the same thing. So with that, we start to design all our formulas like this. We start to use mine for everything we do to find the service in the same environment. And so doing this, we don't really have to change this formula in different environments. Since there's a relation between all these servers, just formula handles that. Then we host template. It's similar. It's much simpler, actually. This is the generic one. We didn't want to use DNS in our environment, just not to have that dependency and not to manage one other thing. So instead of that, we wanted to put all servers IP address in the host file for all servers. But obviously, we don't need a web server in ORD to know a web server in London. They don't talk never. So here, this is done by environment ID. So in each environment, we find all the servers and put those servers in that host file for each server. But this doesn't work for Xenos or Greylock as well, because they are in just one location, and they had to know all the servers in all the environments. So in Xenos case, we check Xenos server roles. So this finds all Xenos servers in all the environments. And then checks the project, if it's the same project, because we might manage more than one project in the same environment, in the same submaster. So it ensures that it's a Marconi project in this case, for example. And then it will find the IP address using mine. In this case, it finds a public IP address because Xenos has to use public IP address. These are different locations. In the previous case, it will be the private IP address because they are in the same environment. So that's kind of it. So we use grains to mark minions with project, purpose, location, and role. So we know what a minion or where a minion belongs to. Then we use pillars to define global rules per role, and also to define environment rules for per environment. Then we use mine to collect all this information. That's the key piece of everything we do. And then we use environments and directory overlay. So that gave us this base environment where we put everything, and on top of that, we use prot, test, whatever we have to use. So it's much easier to create new environments. We don't have to replicate same data more than once.